All right, so for the warm-up, you are solving for the variable in the problem. In that very first example, we have 8 equals 4m. So the value of m that makes that true is 2. In number 2, this is sort of a variation of y equals mx plus b, the form for the equation of the line we're going to look at today, where in this variation of it, they have the m, the x, and the y, and they're solving for the b value. And same with the number 3. However, this time we're solving for the y, or the x value given the y-intercept, and the slope. So again, the goal of today is to talk about the equation of a line in slope-intercept form. Slope-intercept form is y equals mx plus b. So in y equals mx plus b, the m value will always represent the slope, and the b value represents the y-intercept, which, as we discussed yesterday, the y-intercept occurs when the line crosses the y-axis and the value of x is 0. All right, so our goal is to find the slope of the line by rewriting the equation in y equals mx plus b form. So again, this is in a variation of standard form. So what we're going to do is solve for y. So we're going to add 7x to both sides. And then divide by 2. So we get y equals 7/2 x plus 4. And then the slope of the line is the value in front of the x. So the slope is 7/2. When identifying the slope, you do not write the x variable. The x represents a point on the line. It is not part of the slope. And just to continue reiterating what we did yesterday, the y-intercept would be 0, 8, comma 4. The y-intercept is the starting point of our graph, and y equals mx plus b. The y-intercept is the b value, and it occurs when x is 0. Find the slope of each line by rewriting the equation in y equals mx plus b form. So we subtract 3x, divide by 2, and our slope is that negative 3/2, and my y-intercept is 1/2. And as an ordered pair, it's 0, 1/2. Remember that a y-intercept is a y value. Okay, in this case, we're going to rewrite that again. So we have 1/2 x, or 1/2 y, equals -2/3 x plus 1. To get rid of 1/2, you multiply everything by 2. So we get -4/3 x plus 2. So my slope is -4/3, and my y-intercept is 0, 2. We can generalize a relationship between standard form and slope-intercept form. So what we're going to do is solve for y. And what we see is that in standard form, the slope of the line will always be -a divided by b, and the y-intercept will always be c divided by b. So any c, a, and b value can be plugged in and will hold true. We can write equations of lines being given information. So it says the graph intersects the y-axis at the point -2 and goes through the point -4, -1. If it intersects the y-axis, then that is my y-intercept. So that means that that is the ordered pair, 0, -2. So I have two choices at this point. I can plug in -4 and -1 for x and y. And -2 in for b. And I can solve for m using y equals mx plus b that way. Or I can find the slope of the line the way we did in section 3 by taking y2 minus y1 over x2 minus x1. So what you'll notice is either way, I get a slope of -1/4, a y-intercept of -2. So that means the equation of the line is y equals -1/4 x minus 2. In the next example, you're given the slope and a point. In this case, that point is still representative of the y-intercept because it's 0, 4. So that means that my m is 4/3 and my b value is 4. So I can plug into y equals mx plus b. And the equation of my line is y equals 4/3 x plus 4. Okay, the next equation of a line form is known as point slope form. And actually, it's so important, it's on my board right now because we used it in calculus today. So point slope form is y minus y1 equals mx minus x1. So we use this form if the point we're given is not a point that is the y-intercept. So this form is used when it is a point that is something other than the y-intercept. So in this example, we were given the slope and the point. So this is my m, this is my x1, y1. So I'm just going to plug into point slope form. So it's y minus y1 equals mx minus x1. And then it's asking for standard form. So I have to get this in ax plus by equals c. So we're going to distribute the 3. A minus is like a positive. So 3 plus x plus 3. And then we're just going to move the numbers to the left and the variables to the right. And I get 3x minus y equals negative 8. Example 6, y minus a minus 2 equals 2, x minus 4. So you get y plus 2 equals 2x minus 8. And then that becomes adding 8 to the other side, so you get 10. And then we have 2x minus y. Slope and point. This one's a little trickier because you have a fraction. If you want to, you can multiply out the fraction at this point so that you can get rid of your 6 in the denominator. So you get 6y minus 36 equals 5x minus 25. And then combining like terms, you get 5x minus 6y equals, and you would add 25 to negative 36. So you get negative 11. Number 8, we don't have a slope. So first I have to calculate a slope. And then plug in. And at this point, you can pick either point to plug into the equation. And in standard form, we get 2x minus y equals 11. In this example, 5, 0 is the x-intercept. So we still need a slope. So you start by finding your slope and then plug into point slope form. If I have a 0, that's going to be the value I plug into my point slope form. So I'm going to use the x-intercept point. And what's nice about this example is it's a slope-intercept form, so I can quit where I am. So given 2 points, you must find your slope. And then plug in to your point slope form using either of the points given. So you could do y minus 17 equals negative 9/4 x plus 10, or y minus a minus 1 equals negative 9/4 x plus 2, and then simplify. Either way, when you simplify, you should get the same answer. So 9/4 times 2 becomes 9/2 minus 2/2. So you get negative 9/4 x minus 11/2. Okay. So for your homework, you're doing the next page in that packet. It's very similar. Just be careful to make sure you put your answer in the correct form. So that first page is slope intercept, which is that y equals mx plus b. And on the back, actually, I'll let you do slope intercept again. So no standard form.